Yes, students, before proceeding with this today's class regarding the wind load application of the frame structures, before that, I would like to ask you whether you have proceed with the concrete design structures. That is your present assignment. Have you done anything? Any of you can respond. Hello. Has anyone done anything with the modeling of the structure? And if you have faced any challenges or any obstacles, we can discuss on that. So can you please let you know what you have faced? So no response from any of you. So what I will assume that you haven't started or you have started with and completed without any obstacle. Yeah, please. কি প্রবলেম আমাকে একটুখানি যদি বুঝিয়ে বল। না ওয়াইড রেঞ্জ মানে তো একটা ভার্টিক্যাল ডিরেকশনে তোমার একটাই ওয়াইড রেঞ্জে তুমি একটা গোটা স্ল্যাবকে পাইতে। এবারে তোমাকে প্রত্যেক কটা প্যানেলের জন্য তাহলে সেপারেটলি এক্স রেঞ্জ এবং জেড রেঞ্জ দিয়ে সেই প্যানেলটাকে ডিফাইন করে দিতে হবে। ওই প্যানেলটা যেখানে পড়ছে মানে যে এক্স রেঞ্জের মধ্যে পড়ছে সেই দুটো ভ্যালু এবং যে জেড রেঞ্জের মধ্যে পড়ছে সেই দুটো ভ্যালু দিলেই ও অটোমেটিক্যালি ওই প্যানেলটাকে নিয়ে নেবে। পার্টিকুলার একটা ওয়াই দেখতে পাবে, সে ধরো তোমার 6 মিটার হাইটে ওই প্যানেলটা আছে, সুতরাং তুমি ওয়াই রেঞ্জটা যদি তুমি 5.9 to 6.1 দাও তাহলে তো 6 মিটারের এই যে প্যানেলটা আছে সেটা নিয়ে। এরপরে তোমার করসপন্ডিং দুটো এক্স রেঞ্জের ভ্যালু এবং জেড রেঞ্জের ভ্যালু দিয়ে দিলে ও গোটা ব্যাপারটাকে কনফাইন করে ফেললো ওই এরিয়াটার মধ্যে, এবং তখনই তুমি ওই প্যানেলটা দেখবে আইডেন্টিফাইড হয়ে গেছে এবং সেখানে তুমি ফ্লোর লোডের ভ্যালুটা দিয়ে দাও, দেখবে শুধুমাত্র ওই প্যানেলটার উপরেই পড়ছে। কারণ তোমার যদি ওয়ান ওয়ে ডিস্ট্রিবিউশন হয় ডেফিনেটলি তুমি ওয়ান ওয়ে লিখে দেবে সেখানে, সুতরাং ওয়ান ওয়ে ডিস্ট্রিবিউশনই হবে। বাই ডিফল্ট ওটা দুটো লম্বার সাইডেই লোডটা পড়বে, শর্টার ডিরেকশনে লোডটা হবে। তুমি কি এইখানে অন্য কিছু করতে গেছিলে মানে?
হ্যাঁ স্যার, অ্যাকচুয়ালি আমার ক্ষেত্রে প্রবলেমটা হয়েছে যে আমি ফার্স্টে ডিফল্ট দিয়ে করেছিলাম, মানে ফ্লোর লোড পুরো ডিফল্ট যে রয়েছে সেটা দিয়ে করেছিলাম। এবার পরে যখন ওয়ান ওয়ে ডিস্ট্রিবিউশন দিচ্ছি সেক্ষেত্রে আমার ওই টু ওয়ে ডিস্ট্রিবিউশনটাও ওই অ্যাক্ট করছে। তো মানে
তোমাকে যেটা করতে হবে এবারে তোমার গোটা প্যানেলটাতে তুমি গোটা ফ্লোরটাতে তুমি টু ওয়ে দিয়ে দিয়েছিলে, এরপরে তোমাকে যেটা করতে হবে সেটাকে ওই ফ্লোরটাকে বিভিন্ন প্যানেলে ভেঙে নিতে হবে করসপন্ডিং এক্স রেঞ্জ এবং জেড রেঞ্জ দিয়ে। তাতে যেটা তোমার হবে প্রত্যেকটা প্যানেলকে তোমাকে সেপারেট করে নিয়ে যেখানে যেখানে যেরকম লোড আছে সেখানে সেখানে সেটা করতে হবে। তোমাদের ক্ষেত্রে যেহেতু গোটা ফ্লোরটা দিয়ে একই লোড ইন্টেন্সিটি পড়ে গেছে, সুতরাং এটা হয়তো তোমাদেরই পার্টিকুলার প্রবলেমটার ক্ষেত্রে সুবিধা, কিন্তু অনেক ইন্ডাস্ট্রিয়াল স্ট্রাকচার বা অনেক রেসিডেন্সিয়াল স্ট্রাকচারেও এক একটা প্যানেলে এক এক রকম লোড করা, সেক্ষেত্রে কিন্তু তোমাদের কি এক্স রেঞ্জ এবং জেড রেঞ্জে ভেঙে নিয়ে গোটা ব্যাপারটাকে করতে হবে, আদারওয়াইজ ব্যাপারটা কিন্তু হবে না। সুতরাং প্রথম থেকেই তোমরা প্রস্তুত থাকো, প্রত্যেকটা প্যানেলকে তোমরা এক্স রেঞ্জ এবং জেড রেঞ্জে ভেঙে নিয়ে ওকে।
হ্যালো স্যার।
হ্যাঁ সঞ্চয়।
স্যার বলছিলাম যে যেটা অর্ঘদীপ বললো, মানে ওই একটা কোনো পার্টিকুলার স্ল্যাবকে আমি চেঞ্জ করতে গেলে একটা উল্টো দিকে টু ওয়ে লোড দিয়ে সেটাকে নিউট্রালাইজ করে তারপর ওয়ান ওয়ে দিলে ওটা কি হবে কোরম ভাবে?
হতে পারে তুমি ওই পার্টিকুলার প্যানেলটাকে ধরে নিচ্ছ উল্টো দিকের একটা টু ওয়ে লোড দিয়ে ওই প্যানেলটাকে নিউট্রালাইজ করছো, করে নিয়ে তারপর ওই প্যানেলে তুমি একটা ওয়ান ওয়ে লোড, সেটাও হবে, সেটাও হবে। কিন্তু লোড কম্বিনেশনটা করার সময় কিন্তু একটুখানি সতর্ক থেকো, যখন মানে ওই গোটা ব্যাপারটাকে কিন্তু একটা লোড কেসের মধ্যেই করতে হবে।
ওকে ওকে স্যার।
আর আর কোনো প্রশ্ন রিগার্ডিং ফ্লোর লোড অর এনি আদার থিং যারা ট্রাই করেছো? বাকিরা কেউ কেউ কি ট্রাই করনি এমন কেউ আছে যে এখনো পর্যন্ত শুরু করনি? So আর যদি কারোর কোনো প্রশ্ন না থেকে থাকে then we can proceed with the wind load scenario. আমি একটা মানে আমার এটা আজ by today's agenda is basically creating a particular frame structure, a small frame structure that may not match with your problem or the problem on that day Soshi ma'am or Shubhashi sir has created for that purpose. My model may be different to someone. This is a sample model, and I will try to simulate the wind load on that particular frame structural model. So, in the model, the thing is that this time, this is the first time you will see that definition of a load and the application of a load. Before that, you haven't used such scenario because the definition of the load and application of the load has occurred through the same command. Say for example, floor load. You have defined the floor load as minus 5 kilonewton per meter square and applied the floor load in the particular panel defined by X range, Y range and Z range through the same command. So application and so definition and application of that load is done simultaneously through the same command. This applies to the member load. You have defined the member load as something kilonewton per meter on a wheel as a uniformly distributed load, and in the same command you have defined the member number on which that member load is acting. So definition and application of that particular load has done through the single command. But there are few types of loads. Those are to be defined first, and then those loads are applied on the whole structure or a particular member or a particular panel. Such loads are actually earthquake loads, wind load, moving load, or any other load that you will see in short a while when I will demonstrate the whole. So this definition part is very much important because when opening that particular input file, you will see the first command is define. First, it will be defined under the load definition section. You will see define wind load, define earthquake load, something like that. And in subsequent load cases, those definition will be referred, and those definition will be referred, and those forces are applied on the structure. So let us now see how to do that. Okay, so let me share my screen. So let me know when you can see me. Let me know when you can see my screen. Can you see my screen?
Yes, sir.
Okay. So this is the SCADPro Connect Edition screen, and just going beyond that particular one, you can see at the bottom of my screen that there is a number called 19. There is a webinar. Design concrete structures with confidence, comply with seismic requirements. You can this one. That particular webinar was done on 9th of September. So these types of webinars, which are open to all, are actually circulated from MP systems to all the users, so that you can attend those particular sessions. So this is just information to you can have a look to those list of webinars that will happen and you can join those webinars. This is free of cost, entirely free of cost, any license holder because you are enjoying the student's license. So apart from that, some other webinars are there. So you can find the webinars much more interesting to you. So you can definitely join as a student of this university. So I will encourage you to join such webinars. Okay, so come to this point. So we have defined a file name, wind load building, and location is stored. This is an analytical model. And unit system, it is we will take the metric unit system rather than the English unit system. You know what is English unit system? Please interact. You know what is English unit system? The length and the forces. The English unit system is basically the length is defined in either inch or feet, and the force system is defined in kilo or pound. So rather than that, we will prefer the force unit to be kilonewton, and the length unit is in meter or millimeter, something like that. So we have selected the metric unit system here. Then we go for creating that particular model. So we go to create. So we come to the main window of StatPro model. First of all, we need to create a particular structure. Rather, we take help of the structure wizard. We take help of the structure wizard. This structure wizard will help us to create a model parametrically within a short time. So in this structure wizard, we can create a frame model. From the drop-down list of the model type, there are truss models, frame models, and any type of things. We can create a frame model, and we can create a bay frame. You can see the bay frame here. You can see the bay frame. You can drag it here. It will require the requisite parameters for creating a bay frame. So take care of that. These all the units are in feet. So cancel this one. Go to the file, select units, and select unit meter. Okay. So then again repeat that particular scenario. Now we are meter. We are using the system meter. So let us define a very small frame. It's a length of 12 meter. Okay. Let it 18 meter. Number of bays along length 3. Height 15 meter. Say make it 9 meter. Sorry. Make it 6 meter. Number of bays along height is 2. And width is 12 meter. Number of bays is 3. So how it looks like? It will look like this. Okay. So if you don't like this particular geometry, you can also edit by double clicking on this. You can raise the height up to 9 meter with a number of bays 3. So apply it, it will change the model accordingly. So this is a very simple way of creating such models. Okay. Now we have created this model in structure wizard. Now we need to take this model from structure wizard to StatPro. From structure wizard to StatPro, we need to port the model, or we need to export the model from structure wizard to StatPro. How we can do that? We can do by using this command transfer model. Here is an icon. This is transfer model, or we can have the file menu, merge model with stack pro model. Those are same functions. So merge model with stack pro model from the file menu. If you click on that, the structure wizard will ask you, would you like to transfer or merge this prototype into stack pro? Obviously, you will press on yes, and it will ask you at what location of the 000 of the model created in the structure wizard will be placed. So in this particular case, we can tell that the 000 of the structure wizard model will coincide with the 000 of the stack pro. Okay, so that particular model is transferred in stack pro. Okay, fine. Now we will do something with this particular model to make it a model which is not perfectly asymmetric. We'll create this one, or better, we will do first define the wind load and apply this one. Then we will create. So we will modify this particular model to create a different one. Let it happen. Okay. So up till now, it is only the skeletal structure. No member properties, no support, no loading, etc. Okay. What we will do? We need to define the properties. Let it be a concrete structure. Properties. We need to define the properties of the column sections and the beam sections. Say for column section, we need to define the rectangular section. Say for example, you can suggest any section. Please suggest any section. What should be suitable ZT and YT value? Let's see your ideas. Please suggest any value ZT and YT.
Y is
Parallel to,
there is 250.
okay, ZT is 250. So it is 0.25. Just to let you know, whenever you are going to use the column dimension as per IS 456, as per latest IS 456, which is in a seismic zone, do not encourage the user to select anything width of the column less than 300. So I would rather suggest you to take it as 0.3, and YD you have suggested 0.45. That is fine. So 0.45 meter is the YD and 0.3 meter is ZT. What is the material? We need to define the material also, which is already taken as concrete. You can see this part. So all the column sections are 0.3 meter width and a depth of 0.45 meter. So we can add this one. This will take care of the column sections. And regarding the beams, take the ZT of 0.3 meter and make it 0.6 meter. So 0.5. Okay. So we have defined the beam sections and the column sections. So we need to assign the sections, the column sections, to all the columns, and next we need to define we need to assign the beam sections to all the beams. How we can do that? We just go to the select option. Select beams parallel to Y. In a single click, you can select all the column members. So in the beams category, you can go select beams parallel to Y. This will select all the column members which are actually parallel to global Y direction. Now you can assign those. Assign to selected beams is already selected. So we can assign that particular section to all the column members. We assign this one and confirm that. So now all the column members are assigned with our assigned section of 300 millimeter by 450 millimeter. Then what will happen for the beams? Now we have selected the beam section. Similarly, we select all the sections parallel to X and press the Control. Select all the sections parallel to Z. So now all the sections parallel to X and all the sections parallel to Z both are selected, and we will assign our this particular section, section that we have assigned for the beam section to these sections. Assigned to selected beams are selected, we will assign this. Okay, so now it is done. So nothing is left which needs to be assigned. Now we go for the materials. Did you need to assign the material anything for anyone? No, because we already have assigned concrete while we were assigning the section. So that is already done. Then comes specifications. We don't have any special specifications required for this particular structure. Then comes support. We need to create a fixed support to all the base nodes. So fixed support is given. We need to add the fixed support. The fixed support is created, and what we need to do, we need to assign this particular fixed support to all the nodes at the base. I am modeling this particular total system in front of you because this will create a form of recapitulation to what you have done. So if you have any question regarding this one, you will definitely ask me during this time. Okay, so we select one particular view. Now at one go, you select all the nodes which are actually at the base level. You can check by changing the view. You see all the nodes at the base level are assigned with are actually selected to create the support at that nodes. Now assigned to selected nodes is already selected, and I press the button. All the foundation nodes are assigned to the fixed support system. So now my modeling is complete apart from the loading system. So as a fast load case, we can do actually one particular thing. Load case details. We can create one load case, primary load case. We can add the self weight. You can add the self weight command to that. Self weight y factor -1. So that is added. And that particular self weight, you can see the small red question mark is there at this location. The self weight y with a factor of -1 will be assigned to all the members of this particular structure. So select assign to view and then assign. So all the members of this particular structure will be assigned with the self weight command with a factor of -1. Okay. Now come to our main agenda. Definition of wind load and application of wind load. Definition of wind load and application of wind load. You can see in this load and definition panel, just above the load case details, there is one definition. This definition has all the points, all the loads that needs the definition. Vehicle definition, just in a nutshell I can discuss with you. Vehicle definition, when we are going to analyze a bridge structure or something which is subjected to a moving load, and we need to define that particular vehicle, how it actually rolls over the bridge or something system. So that vehicle definition is needed, and that particular definition is done under the vehicle definition system. In the dynamic analysis part, we need to define the time history loading. Time history loading, the definition of the time history load is defined here. Then wind definition, that is the definition of the wind load that will be acting on the structure. Then snow load. Then reference load definition. This reference load is somewhat different, we will discuss it later. Seismic definitions, that is when we'll be going to define the IS 1893 load, that is the seismic load. That particular loading is defined here. Also, there are pushover definitions, pushover loading, pushover type of analysis, that is the performance analysis of structures are possible in StatPro. Then direct analysis definition. Direct analysis is a different kind of analysis which is required if you go for any analysis or design for the American Steam Code. You require this type of analysis, and then starting load definition, etc. So basically, these type of loading system are need to be defined first and then applied. You can see the self worth, which is defined and applied through the same command here, but these type of loading systems, so such as vehicle, time history, wind, snow, seismic, these are to be defined first and then are to be applied on the total structure. Okay, so let us concentrate on the definition of wind load. So wind definition, you click on wind definition and press add. When you add it, it will ask you the type number and the comments. Why type number and comments? Because in StatPro there is a facility that you can define multiple wind load definition. Multiple wind load definition means you can define a wind load of some kind. You can define another wind load. You can define a type 3 wind load, something there. So multiple wind load definition is possible in StatPro, and in some cases, in some practical cases, it is required, because it may so happen that you are going to analyze the structure for 2 or 3 different wind loading. One may be for gust loading, one may be for mild wind loading associated with some other loading, something like that. Or it may happen that up to a certain height of the structure, you don't want to consider the wind load, because that particular structure is have a 20-story building, and up to 10 story, that particular building is surrounded by densely populated building frames in all the 4 sides. So in that particular case, you may not be interested to analyze or to apply the wind load of that intensity if that particular structure is situated in a barren land. In that particular case, all the floors of that particular building is subjected to severe wind. Rather, in this particular case, when it is in the densely populated area, the engineering charge may decide that for the first 10 stories, we will consider less amount of wind load, as because it is densely populated other buildings. But that is so multiple wind load definition are possible in StatPro. That's why this number exists. Okay. So the first number is type number is 1. This type number is important because whenever we refer in future this particular wind load definition in any other part of the input file, we will require this type number. So type 1 wind load 1 is actually defined, and we add this particular one. So you can see in the right hand side of this particular loading definition window, the type 1 wind 1 is actually is appeared. Okay, so you close this particular one, then click on type 1 wind 1 under the wind definitions and click add. Now a particular dialog box for wind definitions is appeared, and we need to define the intensity and exposure for this particular wind load with reference to this structure. So select type is another one option is there, that is custom. What is there? Three codes are actually there. Actually total 4 codes are there. One is SP code. SP code actually Russian code. SNP is also another Russian standard, and GB is the Chinese standard, and also at the bottom of calculate as per ASC7. ASC7 is the American standard. So these actually 4 wind loads are already implemented in STAC. We use IS 875 part. Which part? Can you tell me which part? IS 875 part 3. Yeah, it is 875 part 3. And if you are aware of the latest version of the code, it is the 2015 version of the code. So 875 part 3 2015 is a rather new code, because the previous version was 1987, and that particular wind load is changed a lot, has undergone massive change due to the change in the wind scenario over the subcontinent. So as the wind code has done a lot of change, so my suggestion is to have a look to the 875 part 3 2016 version of the 2015 version of the code, and that particular code is required, because you need to go through that particular code and its relevant clauses, because in your anyway, but what is actually what is more important, that that particular 875 part 3 2015 version of the code is not implemented in STAC. So what you load intensity as per the rules of the 875 part 3 2015 version of the code, and that Kolkata. What is the basic wind speed for Kolkata? Do you have any idea? So, Kolkata and the surrounding region, the basic wind speed is 50 meters per second. 50 meters per second. So 50 meters per second unit in meters per second unit. It is difficult to imagine. It is difficult to imagine how severe the wind is, the basic wind speed. So So basically, the basic wind speed is 180 kilometer per hour. If you convert the meters per second to kilometers per hour, it will become 180 kilometers per hour. So 180 kilometers per hour is not a matter of joke. Can you tell me what was the maximum wind speed that we have experienced during the in the Amphan? Any idea?
তো স্যার আপনার আওয়াজটা কেটে যাচ্ছে।
শুনতে পাচ্ছ এবার? হ্যালো, শুনতে পাচ্ছ?
Yes, sir.
So my end there is some problem. So can you view my screen now? তোমরা কি আমার স্ক্রিনটা দেখতে পাচ্ছ এখন?
No, sir, presentation off আছে।
Presentation of it. One second, please. নেটওয়ার্কের প্রবলেম হচ্ছে শেয়ার করছি। দেখতে পেলে আমাকে একটু জানাও।
Yes, sir, it's presentation off.
ওকে, তোমরা লাস্ট কোনটা শুনেছো আমাকে একটুখানি বলবে? কারণ আমি তো অনেকক্ষণ পর করে গেছি।
Basic wind speed of
রাইট রাইট। তো এখানে যখন মানে আমফান, when the Amphan hit this particular state or this surrounding region, do you know what was the maximum wind speed?
120 kilometer per hour.
Around that 120 kilometers per hour or 130 kilometers per hour. That was the range. So our basic wind speed for Kolkata, our basic wind speed, not the design wind speed. For the design wind speed for Kolkata was there as 180 kilometer per hour. So that is the basic wind speed is considered for design of any structure in and around Kolkata. Okay. So first of all, 180 kilometer per hour, that is the basic wind speed. But there comes one design wind speed. So design wind speed, that is the VB, that is the basic wind speed, and then comes VZ. VZ is equals to K1, K2, K3 times, or K4 and K5. All that these are the factors, K factors, as defined in the 75 part 3 code. And you need to go through all the definitions of the K factors. Those are used. The K factors are multiplied with the design, the basic wind speed to get the design wind speed. Then that particular design wind speed is actually calculated as per the Vz, from we get Pz. Pz means the design wind pressure. So 0.6 Vz square is the normal equation that this particular code used, where Vz is equal to meters per second, and then that particular Pz is of Pz actually design wind pressure. So you need to define this. You need to define this actually Pz, and that particular part you need to calculate by your hand calculation as per the codal provisions. Okay, so you need to define those particular things actually as per the codal provisions. So this particular, up to this particular part, you use the dimension of the building. You need the parameters like where the building is situated, the dimensions of the building, the surrounding obstacles of the building, the slope of the ground where the building is situated, etc. To define those K1 to K5, and then from VB to VZ, and from VZ to PZ. This calculation we need to do as per the 875 part 3 2015 code. Once you get the PZ, that is the design wind pressure, that particular value you can input here. Okay, you understand it? Any queries, please raise it. Okay. So now, by your hand calculation on a sheet of paper, you have got the value of PZ for this particular structure. That is the design wind pressure. That particular value you need to input in this intensity field in kilonewton per meter square. Okay, you understand that? In the unit of kilonewton per meter square, that you need to input that particular. Okay, so you know the intensity of that particular load may vary over the height of the structure. As you are very much close to the ground, your intensity of the loading is lesser, and as you go higher, the intensity of the pressure of the wind load will be higher. So it is kind of a parabolic distribution theoretically. Theoretically, it's a kind of a parabolic distribution. You may get a very less value at the bottom of the structure, and you will get a higher value at the top of the structure. And theoretically, it is a parabolic distribution. But in StatPro, you can simulate that parabolic distribution, or you can assume that that is almost a stepwise distribution along the height of the structure. So you can define that particular distribution as furnished in this table that you are seeing on my screen. Say for example, you can define it is 5 kilonewton per meter square. Sorry, it is 3 kilonewton per meter square up to a height of 10 meter. Then it is 5 kilonewton per meter square up to a height of 20 meter. Then you have 8 kilonewton per meter square up to a height of 30 meter, and then it is 12 kilonewton per meter square up to a height of 40 meters, something like that. So something like that. So how the stat will interpret? So up to a height of 10 meter, from 0 to 10, the pressure intensity is 3 kilonewton per meter square. From 10.1, 10 plus to 20, it is 5 kilonewton per meter square. From 20 plus to 30, it is 8 kilonewton per meter square. And from 30 plus to 40, it is 12 kilonewton per meter square. You understand this one? So This is the pressure intensities, these values 3, 5, 8, 12, and the corresponding height. You have pre-calculated with the help of IS 875 part 3 code. That is done, and you are going to input those particular values in this particular field, but with no reference to the IS 875 code, because STAND cannot identify the IS 875 code. Maybe in future, when the IS 875 design procedure and parameters will be implemented in STAND Pro, definitely that will be implemented in some time. So in that case, you may define the 875 part 3 window in a different way. But until and unless it is not in the domain of STAND Pro, you have to define that particular window as per the method I have told. For example, if you are interested how the calculate as per a height of 10, we define the wind intensity is 3 kilonewton per meter square. This is just a value I have assumed. This may not be. This 3 is abstract value. I have just taken. There is no mathematical calculation based. So I have defined the wind load up to a height of 10 meter. The intensity of the wind load is 3 kilonewton per meter square for this case. I this particular one. Then it asks me the factor of exposure. What is exposure? Exposure factor is nothing but the presence of openings in the face where the wind load is. Where the faces which are facing the window. Say for example, we have some windows in the external walls. You might that the no internal walls or no internal part of the structure will face this particular window. So only the external walls will face the window. The frames which are external or at the boundary of the structure will face the window. So presence of openings in form of doors, windows or balconies or things like that will affect the exposure factor. Exposure means what is the percentage of the area which is exposed to the window. As in STAND Pro, we are not going to model the panels for doors and windows or something like that. So it is a difficult software to assess the area that is exposed. Even as we know, the area of area of the building where we have the doors and windows, it is very difficult to calculate the percentage of area of the face area of the building which is resisting the wind load. So we take some average value. We take some average. We can take 0.9 or 0.85 or 0.8, something like that. Some type of factors generally take. So 0.8 is a very common value. Any value from 0.8 to 0.9, you will see that the now you see that is the wind one, then intensity defined, and the exposure is 0.9, and there is a small red question mark. So this particular exposure factor need to be assigned. These exposure factor need to be assigned to the points which are facing the wind. Ideally, what happens? Ideally, the peripheral faces, peripheral nodes of the building need to be assigned with this exposure factor, because in a particular panel, the tributary area of that particular node will be multiplied by this factor. The tributary area of a particular node multiplied by this factor, exposure factor, will give you the actual area on which the window intensity is at. So, ideally, we should assign all the peripheral nodes of that particular structure with this factor. But for simplicity, we can assign this to all the nodes of the structure, because we are sure that no internal node, the assignment of this particular factor with any internal node will not affect the result. So, rather, we will assign this exposure factor to all the nodes of the building, but keep in mind that only the external or peripheral nodes of the building will do some calculation with this exposure factor. Any internal node will not use this exposure factor for any other calculation or even for the wind loading calculation, as because the internal nodes are unaffected with the application of this building. Okay, so now we assign this particular assign to view to all the nodes of this particular structure with this exposure factor. Okay, so you can see that all the nodes are actually assigned with this exposure factor. Plus, keep in mind only the peripheral nodes will use this exposure factor for the wind load calculation. Okay, now the definition of the wind load is complete. The definition of the wind load is complete. You understand the point? The definition of the wind load is complete. We need to assign this particular wind load to some structure or to some face of the structure. Okay. So now at this point, we go to the input file and we'll check how it looks like. We go to the input file, the command file editor. We need to save it first. You can see that stat space is there. Joint coordinates, member incidences are done. Material definition is done. Member property is defined for beams and columns. Constants in the form of concrete material. Any other specifications are not done. Supports are already defined, and you see this new 3 lines. Define wind load, type 1, wind 1, intensity 3, height up to 10, exposure 0.9, joint 1 to 64. So these 4 lines actually are actually with a wind load definition. Okay, so this defined wind load defines the wind load on this particular structure. Then load type, we have already defined the self-weight load, etc. Okay, we close this particular one, and our next task is we will assign this particular wind load on this structure. Okay, so we go to the load case details and add another load case. Another primary load case, that is number 2, load case 2. Okay. We take this one and we will go to the wind load. You can see the wind load is there. So this wind load is there, and you can see the select type. Select type means if you click on the drop down box, you will see that only one type is available. That is quite normal because we have defined only one wind load. If you could have defined there 3 or 4 types of wind loads, then this particular drop down box will make available of all the 3 or 4 wind load types. But in our case, we have defined only one type of wind load. That's all. Okay. Then you see there is 4 options are there. One is X windward face, Z windward face, minus X leeward or sideward face, and minus Z leeward or sideward face. These 4 options are available. So what are the meanings of those things? You just have a note of these naming conventions. X windward face, Z windward face, minus X leeward or sideward face, and minus Z leeward or sideward face. You will see a small particular button here, loading convention is there. Click on that. So you will see that X or Z plus 1 means this is the loading condition. You can see this particular thing. X or Z plus 1 means this one, and X or Z, sorry, X or Z minus 1 is this one, and leeward means that is the internal. Some window is acting from external, that is pressure, and another is suction. The suction is our factor will be our definition will be minus X or minus Z. So in our case we will use X or Z plus 1 or X or Z minus 1. In our case there is no suction because the building is guarded by the peripheral walls at all the 4 sides. But from a factory, from the viewpoint of a factory shed, you need such type of that internal suction type of things, that is minus X or minus Z, or minus X or minus Z minus factor. The right side pictures you will require when you are designing a factory shed also. But for the building structures, you will require the left hand side 2 pictures, X or Z with some factor either positive or negative. Okay. Now, so X plus 1, this is one particular load, and you may or may not define these ranges, but if you define the ranges, I think someone's audio is not muted. Can you please mute? Someone audio is not muted. Can you please mute? Hello? May I request someone whose audio is not muted? Can you please mute? Hello? Can you please mute? Hello? Anyway. Okay, so this particular load case, which we have defined in load case number 2, that is our X factor 1. Okay, then we add this particular one. We close this one. You will see from the X direction, the wind load is acting on the structure, and the concentrated load is are applied at the concentrated loads are applied at the nodal points of that particular face. So now you understand. See, all the corner nodes are the value of that particular arrow, the length of the particular arrow is less. All the peripheral nodes, the value of the arrow is somewhat higher. And all the internal nodes, the length of the particular arrow is maximum. Okay. So this is the value of the wind load. you will not be able to see the individual values until and unless you view that particular load values. But you can have a print of those values, print load values command using the print load values command, or you can, for such type of building structures, you can calculate the tributary area of each and every node, multiply with the exposure factor, and then you can cross check and multiply the load intensity value, and you can cross check the values with that. So that is very simple. But for complex structure or for complex geometry structure, that will be quite cumbersome. But the principle is same. Anyway, let us add another wind load. Which one is that? Load 3. You add this one, wind load, Z direction 1. So that is the wind load from Z direction. Okay. So towards the positive Z and towards the positive X. First, in the load case 2, we have defined the load case towards the positive X, and in the next load case, we have defined wind load towards the positive Z. Now, for the load case details, we add another load case, and for that particular load case, we add wind load X with a value of -1. What will it give? It will give you the wind load towards the negative direction of X. Towards the negative direction of X. And for the, we add another load case. Z with a -1. So now our wind load is towards the negative direction of the global Z. So by using this particular wind load definition and application system, you now will be able to create the wind loads on a structure. Okay. What you can do now? These are the basic load cases. So individual wind load case will not be able to act on any structure. So you have to combine the wind load cases with other load cases. Now it is up to the load combination. So dead load plus live load plus wind load, or dead load plus wind load, or dead load plus 50% of live load plus wind load, something like that. So as per the codal provisions, you have to combine these 4 wind load cases, one after another, with dead load and wind load and other load cases as per the directions of the load, as per the rules of the load combinations as given in the part 5 of 875, or you can refer the corresponding 456 or 800 code clauses. Okay. So this is in nutshell how the wind loads are generated, how the wind loads are actually defined, and how the wind loads are applied on a small building structure. If you have any question, in the second half I will show you this particular building in a different geometrical condition, and other, if time permits, I will show you another feature of that particular window that will be important that may come to your professional life. You will apply that particular window. So what you will learn, how to define the window, how to apply that particular window on a structure, and how the exposure factor acts, and also the different phases of a building where we can apply our wind load values, and the wind loads are applied actually at the nodal points at the face, not on the members. Please keep in mind the wind load, in case where the wind load is applied on the total structure, the wind load is applied on the face of on the nodes which are on the face of the particular wind. So this is the scenario. You can now define your wind load as per the total provisions. Then you apply that particular, define that particular wind load in stack load and apply the wind load on this particular structure. So keep in mind that wind load is basically a lateral load, and ideally it should the intensity should be lower at the bottom of the structure. As you go higher, as I have defined the wind load from this side to this side, intensity is this. That is not the parabolic distribution, but you can simulate the parabolic distribution by keeping the steps very small. So that's the step cutting distribution. So by defining the wind load in such a way, you can simulate the parabolic distribution. Okay. So the rest is similar. You can combine these wind load cases with other load cases and analyze the structure and then do your design as per the model provisions. Those parts are same, but the only difference what I have shown you today about how to define the wind load, its various components, and how to apply the wind load on the structure. So that's the end of my part. So if you have any further question, please raise it now, or you can raise it in the second half too. Okay. So if you have any question, please let me know. Otherwise, we can leave now. Please confirm. Hello, students. Do you have any question, please? Okay. So if you don't have any question right now, we can disperse, and we can meet once again at 2:30 p.m. or you can suggest any other time, 2:45 or 2:30. So let us meet at 2:45. Okay.
Okay, sir.
Okay. Thanks. Okay. 2:45. We will meet you. Thanks. Bye. You can leave now.